Hello everybody, welcome into another lesson. So today's lesson's actually going to be relatively short. We are in general just going to talk about deductive reasoning versus inductive reasoning. So in mathematics, the two types of reasoning used are deductive reasoning, which we have here, and then inductive reasoning, which I'll talk about after this. But deductive reasoning is where a conclusion is based on accepted statements, such as definitions, postulates, previously used theorems, corollaries, and given information. So, all the proofs we've been doing up till now and are going to do in the future in this course have all been based on deductive reasoning. It pretty much fits this description to a T. And then the conclusion must be true if the hypotheses are true. So that's the thing with deductive reasoning. And I have a few examples of that. We're not going to do any proofs today, but I'm going to have 4 statements that we have to try to draw a conclusion from based on deductive reasoning. So let's see. The goal here is to reach a conclusion based on deductive reasoning. So there's going to be 4 statements that we have to try to draw a conclusion from based on deductive reasoning. So the first example is going to be Chan is older than Pedro. So that's the first sentence of the hypothesis of the statements. The second one is that Pedro is older than Sarah. Okay, so we have 2 statements here that we gotta try to draw a conclusion from. We have that Chan is older than Pedro, and that Pedro is older than Sarah. We gotta use deductive reasoning to come up with a conclusion. So in deductive reasoning, we accept these 2 statements to be true. We accept that these will be true. So if Chan is older than Pedro, and then Pedro is older than Sarah, well, based on the information, the only conclusion you could reach is that Chan is older than Sarah. So that's the only logical conclusion you could reach based on deductive reasoning, is that Chan is older than Sarah. That would be the conclusion. Chan is older than Sarah. Okay. How about the next one? We have Valerie is older than Greg. So we know Valerie is older than Greg. We can accept that as true. Then we're given something like Dan is older than Greg. So what conclusion can we come up with these 2 statements based on deductive reasoning? Okay, so it says Valerie is older than Greg. It also says that Dan is older than Greg. Well, we know both these people are older than Greg. Well, Could Valerie be older than Dan? We don't know. We don't have enough information. Could Dan be older than Valerie? Again, we don't know. There's not enough information here comparing Valerie to Dan. So in this case, there's no conclusion. There would be no conclusion to this set of statements because only both of these compare to Greg. Valerie and Dan don't compare to each other, so there's no conclusion with these two statements that we can reach based on deductive reasoning. Two more deductive statements, then we'll go to inductive reasoning. All right. Polygon G has more than 6 sides. So polygon G has more than 6 sides. It also says that polygon, damn, I'm doing it again like yesterday. It's not polyon, it's polygon. Polygon G has fewer than 8 sides. Okay, so based on these two statements with deductive reasoning, polygon G has more than 6 sides. And then it tells us that polygon G has fewer than 8 sides. Well, the only conclusion we could reach here is that polygon G would have to have 7 sides, because that's more than 6 but fewer than 8. So the only logical conclusion based on deductive reasoning would be that polygon G has 7 sides. So in other words, it would be a heptagon. So polygon G has 7 sides would be the only logical conclusion that we could reach out of this. I have one more statement based on deductive reasoning. So let's see. Polygon G has more than 6 sides. Polygon K has more than 6 sides. Okay. What conclusion, if any, can we draw from these two statements? It tells us polygon G has more than 6 sides. It also tells us that polygon K has more than 6 sides. Well, we know both of them have more than 6 sides, meaning it has at least 7 sides, maybe more. But one, it doesn't tell us if, in either case, how many exact sides each one has. We don't know if we can conclude that polygon G has more sides than K, or if K has more than G, how many sides each truly has. So there's no conclusion for this one. So what we have here are basically two useless pieces of information, because we have two different things and they give us no more information than it has more than 6 sides. So we can't reach a conclusion with that. So those were examples of deductive reasoning on top of the proofs that we've already done in this course and will continue to do. Those are all deductive reasoning. Alright, let's talk about inductive reasoning, which we won't do very much of in this course. We primarily in this course will use deductive reasoning. Now, when we get into Algebra 2 and into pre-calc, we'll use more inductive reasoning, along with some deductive, but you'll see inductive more in practice there. So inductive reasoning is where conclusions are based on several past observations. And then the conclusion is probably true, but not necessarily true. Okay. So inductive reasoning is different because with deductive reasoning you actually have laws and properties and theorems and corollaries and postulates and definitions, actual solid concrete things to back up the conclusion from the hypothesis. And it's grounded in what can be proven, what's evident. Inductive reasoning, the conclusions are based on several past observations. So this means the conclusion is probably true. It might be true, but not necessarily true. So let's go over some examples of inductive reasoning. I'll have about 4 examples of that. And some of the greatest examples of inductive reasoning are predicting the next numbers in a sequence. So use inductive reasoning to predict the next 2 numbers in the sequence. Okay. So what's about to happen here is we're going to do 4 examples that we have a list of numbers. We got to try to predict the next 2 numbers. I'm sure most, if not all of you have done exercises like that before. They're pretty simple, but they require inductive reasoning. So, for example, we have the numbers 18, 15, 12, 9, and then it just keeps on going, right? So we're going to use inductive reasoning to predict the next 2 numbers in this sequence. Now, this is where we will largely use inductive reasoning when we get into Algebra 2 and into pre-calc, because we do a lot of sequence and series in those. So you'll see it in practice there. But it would appear that each number goes down 3 from the last, right? 18, then 15, then 12, then 9. So based on inductive reasoning, it's going to look like the next 2 numbers are therefore 6 and then 3. Those would be largely what we would predict. And this means, based on the observations that we've made, that's our conclusion. This conclusion of the numbers being 6 and 3 is probably true. It probably is. But how do we really know for sure? Who's to say the next number isn't 0 and then the next number is -50 after that? We don't really know that. That's why it's probably true, but not necessarily true. And then let's do 3 more number sequences. Not too bad. Okay. We have 1, we have 1/3, 1/9, 1/27th. And then from there, we don't know. So we're going to use inductive reasoning, so in other words, past observations, to figure out what the next 2 numbers of the sequence probably are. If we notice, between the first number to the second number and every subsequent number, you're multiplying the previous number by 1/3. So if we take 1/27th and multiply that by 1/3, you would get 1/81st. Then if you multiply that by 1/3 to get the next number, you would end up getting 1/243rd. So based on inductive reasoning, 1/81st and then 1/243rd would be probably your next 2 numbers in the sequence. But again, we don't really know that for sure, because this is inductive reasoning. 2 more, and then we're good. Actually, let's do 3 more. I have my reasons, but these are just number sequences. So we have 1, 4, 9, 16, yada, yada, yada. Okay. So let's use inductive reasoning to figure out what will be the next 2 numbers in the sequence. Well, it looks like here between the first and second number it goes up by 3. Between the second and third it goes up by 5. Between the third and fourth it goes up by 7. So that would lead us to believe that the very next number is going to go up by 9 from 16, which would give you 25. Which could only mean that the next number after that, based on this inductive reasoning, the next number would go up by 11 from 25, which would be 36. Or what you could have said, another way you could have said this, we could look at this and say, well, isn't 1 squared 1, 2 squared 4, 3 squared 9, 4 squared 16? So then we could conclude the next number would be 5 squared, which is 25, then the next number 6 squared, which is 36. You could have gone either route. But based on inductive reasoning, it looks like the next 2 numbers would be 25 and 36. But then again, we don't truly know that. But more than likely, that's what it is. Alright, 2 more. We have 8, -4, 2, -1, and then +1/2. Then we got to try to predict the next 2 numbers. So let's look at this sequence here. We have the first number 8, we have the second number -4, we have the third number +2, the fourth number -1, the fifth number +1/2. It looks like a mess at first, doesn't it? But it looks like between every single number, you're just simply multiplying by -1/2. So, based on inductive reasoning, if we multiply 1/2 by -1/2, the very next number in the sequence should be -1/4. And then to find the next number, you'd multiply that -1/4 times -1/2, which therefore should give you +1/8. So based on inductive reasoning, the next 2 numbers in the sequence would be -1/4 and +1/8. Then there is one more. This one's going to be a fun one. We have 2, 20, 10, 100, 50, and then it keeps on going. We got to use inductive reasoning to predict the next two numbers in the sequence. This one, there isn't a clear-cut pattern yet between each number. It looks like they vary. So you have 2, 20, 10, 100, and then 50. Well, it looks like between 2 to 20, you multiply by 10, right? And then between 20 and 10, you would divide by 2. And then between 10 and 100, you multiply by 10. And then between 100 and then 50, you divide by 2. So it looks like it alternates multiplying by 10 and dividing by 2. So that means the next number, based on inductive reasoning, we should multiply by 10. So you take 50 times 10, your next number in the sequence would be 500. And then the number after that, you would divide 500 by 2, you would end up getting 250. So based on inductive reasoning, the next two numbers would be 500 and then 250. But then once again, we don't truly know. But that was just a short lesson on deductive reasoning, which is going to be a majority of the course we're in, because proofs are mostly all deductive reasoning. So next lesson, we're going to shift gears a little bit into congruent triangles and congruent figures. The first lesson in the series will be about congruent figures in general, and then we're going to move heavily into proving triangles congruent and methods for doing that. So I hope everyone has a good night. Take care.